give away all your IP. And as we are recording, can we just all make sure that unmute if you want to make a point and ask a question, or keep the microphones on. But welcome everybody to the July meeting of the Drone Research for Advancing Community Healthcare and Medicines Access Network. And we've got some brilliant speakers for you. But first, let's do a little bit of housekeeping. So I just put up Gary's fantastic presentation from last month. As you remember, he gave a superb talk on basically how to control your drone when you haven't got GPS available, using quite a lot of very sophisticated laser technology. So that's up there on YouTube. And then today we've got, as I say, we've got 4 speakers. So we've got Paul from Skyports up first. Then we've got Andy from the University of Southampton, Jens from Intelsius, and finishing off, colleague and co-founder of DRACHMA, Patrick, is going to bring us up to date with some best practice. So without further ado, I'm now going to ask the first speaker. You want to grab the sharing of the screen, Paul?
Yeah, that's my mic on. Hopefully you can hear me. So I'm going to set my scene. So I'm a big fan of video, so I'm going to play a video, which I know is a bold move on a Teams meeting. So hopefully the sound and video works okay for you all. But here we go. I'm just going to play first 5 seconds. I'll just check with you, Paul, that you can hear the sound.
Yep, that's fine.
Great to see that technology that we are using and developing every day, including the operations, can help to make healthcare ready for tomorrow. At Skyports, safety is our highest priority. We want to make sure everything we are doing here is safe. We are working very closely with the CAA together to develop this kind of industry, because projects we are kicking off here are the first of the kind. There are no projects like this right now in the UK.
A GP could be at the other side of the island and needs a defibrillator quickly. He needs penicillin really quickly. He hasn't got it with him. A drone delivery could get it to him with the location services that we have within minutes. It's a lifesaver. It's a connector. It opens the possibility you are in a remote place, but really you're not remote.
I think we'd love for this service to be permanent. It does make the running of the practice much easier.
Great. Well, yeah, for me, I think a picture paints 1,000 words. There's a few things I'll probably reference in there. I'm just going to flick over to my slide deck. There we go. Should be able to. You see that okay, Paul? Can you see that okay, Paul?
Yep, can see that loud and clear. Very good.
Perfect. Thanks very much. Yeah. So when Paul asked me about what's the perfect attributes of a delivery drone, so where do you start with a question like that? But I think from a Skyports perspective, we're agnostic, so we don't make any of this technology you see on there. We work with the right manufacturers. Sometimes that comes out of universities, sometimes that comes out of other startups. But for me, and someone who's always thinking about the customer, it's those people in that video paint the perfect picture, because it's about the problem we're trying to solve. So we pull together the high value inspections or the drone flights in a complex environment. And as far as the manufacturer or the drone manufacturer is concerned, we are the operator. So we form part of that end user, but it's also the end user that we serve as well. So, there's multiple people in that supply chain. But just to set some of the scene of what we were talking about in that video there, the drones are making things faster, the drones are making it cheaper, and making it safer. So we were using that the cold chain storage to deliver some of the drugs. There's other companies out there doing that as well. So there's been stuff in the news recently with Appian working with the University of Southampton, I think, delivering stuff to the Isle of Wight. And this is the partnership we were working on with the NHS that you saw in the video there. So if we go back a few steps to the sort of foundation, it's like, what are we trying to achieve? So in that occurrence, we're trying to connect disparate communities and distributed communities, often over 100K, sometimes doing 20 flights a day. And that serves those end users, which is in this case actually the patient, which then feeds into the GP surgery, which then feeds into us as the logistics provider, and providing that service. So when we look about what makes the right drone solution for us, these are some of the things we might see. So at the moment we're in a stage of the regulatory environment where generally we have a mobile ground control van that you can see in the middle there. That's our short-term route to permanent operations. So what does it mean to those guys? They're looking for a drone that they can easily transport, maybe that is easy to follow, that doesn't break down in service, that's reliable. But then as you look towards the future, we're not always going to have that man in the loop, but it's going to take a while until we get to that stage, until we get approvals from the regulator, where you might see something like drone in a box. So we were actually trialing some of these in certain countries at the moment, but in every situation, it's a proof of concept. It's a proof of concept with the customer. It's a proof of concept with the regulator, and that they're allowing us this sandbox to play in to prove that we can do it safely. And just on the right-hand side there, we see a vision in the future where there will be potentially centralized operations where many drones will operate, fulfilling many missions for many customers, obviously localizing and centralizing some of the less efficient parts of the service. So if we're looking to use these drones in rural areas, maritime areas, surveillance, etc., what is it that forms that ideal attribute? So for me, it's about working through, well, think of it from the regulator point of view. Skyports as an operator, we have to go to the regulator and get approval for every one of these missions or proof of concepts that we put together. Some we have standing permissions approvals for, but on each occasion, they're going to ask us about the type of aircraft, and they'll drill down, depending on the mission, they're going to drill down into the specific components. Do we have a redundant power system? Do we have tried and tested motors? Is the airframe built to withstand various stresses, etc.? And I can't help but think, over the last, 8 to 10 years that I've been involved in this industry, sometimes, I think there's like madcap inventors just sit down, they design their own drone and then just release it to the market. And then it's the operator that spends their time trying to get this through a regulator to say, hey, this is fit for service. So, I mean, on the other hand, we've taken some of those systems and we've put them through rigorous processes of testing. We've got a test site with the Connected Places catapult, sorry, the satellites catapult in Westcott. And we put them through rigorous testing because obviously it's our name, it's our brand name that is going to be on the front of this, and that reputation with the regulator. And on quite a few occasions, we've declined to pursue any further relationships with the manufacturer. And then we're looking at it from there's more than one regulator as well, so it could be from like a privacy perspective. So that's why it's really important, as you saw in the video, with the stakeholder engagement, that they see the benefits. So what does the solution look like for us? It's one that instantly showcases the value to the very end of that supply chain. So the man in the street there that could recognise the value of getting a defibrillator across the island from a GP surgery, and having the right amount of data so that we can support it. Data and IP, so you mentioned it at the start of the call already, Paul, but some people hold that a bit close to their chest, and then that makes it really difficult to try and get the approvals in place to operate these aircraft. And we don't always know what the right fit is for a specific mission, so quite often a use case pops up and we're in such an early part of the industry that we're having to make the aircraft fit the job, and it's an evolution. So those who might recognize a similar evolution from the internet, where use cases came out or applications, and then a load of infrastructure came out that helped support those applications, which then spawned a new wave of applications, which then spawned a new wave of infrastructure. And that cycle went on. And there's some quite well-detailed science papers out there around how that developed. But it's similar with the drone industry. We've now got some really interesting use cases, proven some missions, and that's going to spawn, I think, the next generation of aircraft. And as a Skyports, we'll be looking around to see who that is we can work with. And as we progress, right across that slide, what are those aircraft doing? Well, at the moment they're being piloted, so we need to have some sort of human-machine interface. Sometimes they'll generally be automated. They won't really be autonomous as such, but that's where things are going to be moving to. And again, we're going to be looking to justify to the regulator why we should be allowed to use these. And from a pilot perspective, we need to train those pilots. So the training materials, the training becomes a cost on the operator, which is Skyports, and obviously that gets passed down eventually to the customer in terms of how cheap we can make these flights. Ultimately, with a customer like the NHS, we're looking to potentially supplement, or in some cases displace, road vehicles. So there's a given cost we know for that already, and we can begin to work that out to the pound of where that makes business sense. I think sometimes in the drone industry, people can begin to say get attracted by the technology, but I think from my perspective, I'd really like to think about the customer, like what problem is they're trying to solve. And I spoke to an NHS customer just last week. He's from the C-level of a trust. One of his alternatives was building a vacuum pump underneath the city, where you might put a little container in, it goes down a vacuum tube and shoots across the city. That was an option thrown on the whiteboard. Obviously, wasn't really feasible to build that across the city. So this is the competitors. They've often got the technology, and why we just need to have this more customer-centric focus around what problem we're trying to solve. And you can see that the pilots as well. There was a picture in the video. Sorry, a scene in the video where we were remote flying from central hubs as well. So again, we've got this hangar at Westcott. We see that as potential where we would start that off. How does that fit into the overall picture? How does that fit into the overall regulatory approval? How does that fit into our overall business model? Because ultimately, these things have to make business sense. From our perspective, we've got the capital expenditure of initially purchasing those drones and the operating costs, and some of those, it's not immediately obvious, I think, sometimes when they're designed until they get out of the box and we see on a mission, we look at it and we go, oh, this is quite inefficient. So an example might be the energy storage in the lithium polymer batteries doesn't like being kept at full charge for a long period of time. So that now means our pilots on the ground have to spend their time discharging any batteries that haven't been used, which adds on time, adds on more complexity, etc. And how would that be fulfilled in a real life operation? And I know it says just Oh, sorry, just disregard that. So yeah, my ideal attributes, they've got to be client-centric. You know, we're dealing with dangerous goods, so we might have to go down dangerous goods approvals. And we're dealing with temperature-controlled goods. So how do we keep those drugs at the right temperature? How do we maintain compliance? How do we show there's, you know, there's an element of governance around that. The cargo capacity, we've got volumes we're dealing with. So on the scene there we did with the NHS, we were dealing with quite small packages, but you know, there's other aircraft out there like the Wind Racers aircraft that's dealing with a different part of the supply chain and different weight elements. So I sort of see it a bit like when mobile phones first came out. You know, we had the spin phones, we had the flip phones, we had the big phones. You know, for a while we went down to as small as possible, and we all had like the Nokia 8310s. You know, now we seem to have settled on a form factor which makes sense to most people. You know, it's a big screen, pulls in the apps, but it's taken us quite a while to get there. You know, 20 odd years to get to that point. And I think this is what the drone industry is going through at the moment. Is like trying to find that right form factor or that right tool for the job. And ultimately, what are those lab requirements? There's another company out there that's just won some future flight funding, and they did some work with the Royal Mail. You know, they really had to dive into what the Royal Mail were doing with their aircraft, because as a drone operator, you don't have that business understanding from the postmaster to the logistics manager, etc. And they just give you that little snippet of information, just as we spoke to the NHS last week, which was like, okay, well, once this drone lands on the roof, what happens next? Because we don't just want to dump a load of samples on the roof. Like we've got to join this up. It's a system of systems, right? So we've mentioned on the regulator side of it, so making it regulator friendly. Like how can we push the safety case forward? Do we get the right level of data from the manufacturer? Are we enabling the right sort of permissions? Will it even pass muster with the CAA? You know, there's certain certain architecture of a drone that just wouldn't even pass muster with the CAA for, say, high density city operations. You know, they might approve it for rural operations, but they're just not going to approve it for a city. And you're edging then towards having certified aircraft. And when anyone uses the word certified in aviation, that's a very robust process, often costing lots and lots of money. And that really sort of needs to be designed in from the start. You know, it's very difficult to do after the horse has bolted. Then you've got the other elements of it, the noise, you know, lots of science around there and reports around the noise elements. I still find the noise of a drone quite annoying. It just hits that right frequency, that right noise that just cuts through your brain. As opposed to when I see a Chinook fly over, suddenly it makes me feel excited, like I'm watching an action film. You know, there's some deep psychological stuff in there. But what we don't want to do is alienate the public. And often it's the regulator that front that for the public in terms of making it fit for purpose. So the pilot, mission friendly, you know, we're flying specific missions in specific use cases. Quite often they're probably 45 minutes to 60 minutes. So we can begin to design things around that. You know, there's certain elements of power we need from the batteries, certain element of redundancy. Training human factors, already touched on most of that. But yeah, the human factors, just making sure it's obvious. And there's lots of evidence out there, even from some very professional organizations like the British Army, that have done or made aircraft crash because of human factors issues. Things that actually, you know, they've existed in manned aviation for a long time, and some have been pretty much earned through the spilling of blood. But yet we're, you know, the unmanned aviation industry is still trying to catch up with some of that. And then finally, from a business sense, you know, every time we get approached by somebody that says, hey, we've seen something in the news, like we'd quite like to explore this. We see this as part of our future roadmap. You know, we have to sit down and almost from scratch work out a new model in terms of what these operating costs look like, how many pilots we need for a given mission. If this is an extended operation, you know, it's a watch-keeping system, so we have to incorporate leave, sickness, etc. And also the export controls. You know, a lot of that's got easier now, but you know, when you're moving drones around from border to border, sometimes people or border agencies can begin to question whether that's for some other purposes. And certainly if you're developing some really interesting technology, you know, you've got things like ITAR in the US as well. So for us, we haven't got an ideal attribute because it comes down to that customer, comes down to that business case, and it comes down to, you know, how do we make this work? So we're in a fortunate position that we do stay agnostic and we try and look around for the best tool for the job. But these are all the things that we're trying to look at, and you know, you may be surprised that sometimes, actually, more often than not, we go to someone and they can't answer a significant proportion of you know, the questions we raise there. Conversely, you know, do you go down the route of trying to design drones yourself and then take them to the market? Well, you know, there's probably a reason why Boeing design aircraft and British Airways operate airlines, because that's a very complex business model. But, you know, along the way, there's a very, over years of operating, British Airways have perhaps said to Boeing, hey, this is what we look from a perfect aircraft. You know, we want to reduce our emissions, we want to reduce our noise, and this is what it looks like. But I don't see much from the drone manufacturers world of trying to lock down those of what the customer or the operator needs. I think it's very much sort of hypothetical based, and you know, no validation of those questions. So it's quite a broad overview, and I do have a tendency to rabbit on sometimes. But I hopefully that gives you a bit of a picture of what we have to deal with on a day-to-day basis to deliver some of those real-world missions. There's my details if you do want to chat any more on it, and I will be at Farnborough Air Show this Wednesday if you want to have a coffee.
Fantastic, Paul. Thank you very much. I mean, a very trivial question: will he be flying anything at Farnborough?
Not as far as I'm aware. No. I imagine there will be some UAVs flying around, but I've got to say, I went to our test site. So this is only my 10th day in the company, but I've been in the drone industry for about 10 years. So I went to our test site last week, and my manager thought it was a really good thing for me to do. And I think within about 10 minutes, I'd walked back to the hangar and I got my laptop out because I had other stuff to. I was like, Alex, would you've seen one drone flying around? You've seen them all. Like, this is not the bit I get excited by. You know, the exciting bit for me is fulfilling the overall mission. You know, did we deliver like 14,000 pathology samples over a period of a year? You know, can I look at that dashboard and, you know, can I speak to a GP and understand how that's the bit I get excited about. I mean, I used to get excited about seeing a drone fly, but I think it quickly wears off. Hence why I'm also a little bit dubious about some of the consumer applications of, you know, getting your coffee delivered by a drone. I think it's all quite exciting day one, but I don't think it really fulfills some of those business 101s.
I still quite like the buzz of seeing them and flying them. It's good fun. And Andy Oakley's got a fantastic question. Andy, do you want to unmute and pose your question?
Yeah, so I mean, it's not actually related to the requirements of the drone, but you touched on it earlier. You said you were 72% cheaper than ground logistics. I was just wondering what you've included to calculate that.
I would love to be able to give you the details of who calculates that statistic in my organisation, but I'll definitely find out for you.
Yeah, that'd be grand.
And
so,
I imagine you might be able to pick it apart. And
I mean, I'm doing quite a bit on drone economics, so it'd be great to have a look.
Yeah, and obviously, you know, it's not necessarily a statistic you can apply across the board, because some of that was related to around the stuff in Scotland. You know, so you've got ferries and, you know, ferries getting across and the cost of a ferry not operating, etc., etc.
Yeah.
Hence why actually, you know, in some cases, I don't think a drone would be relevant in a city in all cases, because you know, we've got quite good land logistics that can be utilized in different ways. I think, you know, I like to think I'm an engineer at heart, and I like to think it's about finding the right tool for the right job. And I don't go straight to drone. You know, I like to think, well, you know, what are you trying to solve here? And do we think it is probably the right tool for this on this occasion?
Yeah, it'd be good to talk. I think.
Yeah, definitely. And I'm due to head over to Boldrewood at some point to catch up with Jim and Tom again. So yeah, we'll definitely do that. Yeah,
absolutely.
Thanks. And in Paul's defense, I didn't know you've only just joined the company. I reached out to Skyport and they royally dropped you in it on your first week. So thank you very much, Paul. A very thorough presentation in your new company. That was very good.
No worries.
Do we have any more final questions for Paul from Skyports? I mean, there is part of Andy's question still there. I mean, you are doing operations in some of the sort of extreme parts of the UK. So what about weather and rain? Do you fly on windy days?
Well, actually, yes. When you say about the weather, you know, we might think it's hot here at the moment, but we've got a team of 35 in Singapore currently doing ship-to-shore stuff, and it's already exceeding about 40 degrees there. So there's lots of stuff that the flight ops team. So I'm privy to some of the flight ops team's Slack channels and stuff, and I see some of their updates and some of their reminders, etc. they push out. The human factors one's really interesting, because actually it's making sure that we can make sure the pilots are hydrated, making sure they're taking time, because, you know, the aircraft lands and they've got a specific time frame to be able to swap batteries over, put the new ones on charge, and then hand over pilots as well. And actually part of our operations procedure wasn't making enough time for them to hydrate. So, you know, so trivial, but actually, you know, if your pilot keels over because he's not hydrated, it's something that the manned world thinks of. And then we've also then got the you know, just the simple as like, where do you store that aircraft while you're waiting, or where do you store the battery technology, you know, trying to keep things in the shade. Sometimes, you know, you don't have to think about the really complicated, you know, problems. Sometimes it's the simple ones we need to solve as well. Yeah,
that's really interesting, because from my experience of being involved with drone tests, it's always really cold. But you're right, yeah, absolutely. You're going to keep them hydrated, or they'll keel over, and no drone, it crashes. Cool.
Right, some of the pilots were heading out to the ships, so the big cargo ships out in the ports in Singapore, and actually there was like a double whammy effect, because they're getting heated from the you know, the sun and the effects from that, but actually it was all then radiating back up from the deck of the ship. So you know, they're getting hit by both sides as though they're in like some sort of, you know, they've got like a reflector underneath them. So from what I heard from it, it's seriously uncomfortable.
Okay, right. So my thoughts are with those guys out in hot climates. I feel a bit like that in my office because it's quite warm here. But to keep us on track now, I think you've brought us perfectly into time, Paul. So thank you very much. And Andy, I think you're up next, aren't you?
I believe that's your schedule. So
that's good. That's good.
Is that coming through?
It is now. And just before you start, because you know the form, Andy, anybody that's new to the meeting, if you've got a burning question, pop it into the chat, and then if others think it's a good question and they like it, they can give it a thumbs up, and we'll try and get to the question at the end of the meeting or the end of the presentation. So pop the questions in the chat. So Andy, the floor's yours.
Lovely. So thank you, Paul. I'm going to be talking to you today about some flight trials that we've been doing as sort of a collaboration of different universities, different research projects up in Llanbedr in North Wales. So without further ado, let's get started. So I'm going to run you through the sort of background of what particularly we're focusing on, and then sort of the solution that we're slowly developing, bit on the testing, and then some of the findings and sort of the next steps forward. So the problem that we're trying to tackle is very much all to do with, there are so many use cases, funnily enough, the Skyports are on this, and they are fantastic use cases which people want to exploit, but at the moment there just isn't an airspace management system to be able to cope with all of these. So you get issues of these things called temporary danger areas, where essentially you're putting a brick wall in the sky so that you can have a safe passage for drones to get through without interacting with general aviation. And this is great. It keeps it nice and safe, but you then kind of create a Swiss cheese in the sky of different routes that pilots then have to navigate, and it's just not ideal and it's not sustainable. So longer term, and in certainly denser air traffic areas, there is a view to bring in what we know as UTM, or unmanned traffic management. In Europe, it's known as U-Space as well. And just this morning, you might have seen on the news that the UK is set to have the world's biggest automated drone superhighway, which, as far as I'm aware, this is all going to be sort of UTM based. Very much, we are telling you where you're going. We're going to keep a good track of you so that everyone can happily use the airspace without the Swiss cheese effect. But the issue is, if we do that in a busy area, that's fine. But say we've got our nice friendly operators at Skyports in Scotland, they're flying a drone every hour or two, maybe. It seems a bit overkill to then suddenly throw all of that infrastructure in for such a small operation, relatively. So this is where our concept we're terming Project Lima comes in. So airspace as it stands is classified into several different classes. And so if we suddenly put in this additional infrastructure, and we sort of create a new class of controlled airspace for the UTM, why don't we do something similar but with a lesser control in the uncontrolled end of the spectrum? So class G at the moment, this one here, is pretty much you look out the window, you talk to air traffic control very occasionally, but it's very much you fly where you like. And this is something that we kind of want to achieve with drone technologies. And it all came out of some flight trials that we did in the Solent. So 2 different flight trials, one transporting aseptic medicines from Portsmouth to the Isle of Wight, so that's the bottom left here, and one transporting various different cargoes as part of the COVID-19 air bridge project in the Future Transport Zone using Ultra, so up in the top right. And this was coming out of Lyon-Solent Airport, which is one of the busiest general aviation airports in certainly the country, if not the world, for relative to its size. And it's one of these things where, okay, we've got this temporary danger area, but we're now upsetting a lot of people. And yet a lot of the airspace we were flying in was completely it was uncontrolled airspace. Once you're out of that airfield proximity over the Isle of Wight, it's relatively benign airspace. So what could we do about it? And this is very much where the self-managed airspace concept comes in. So oh, I've just lost it. Am I still presenting?
Yep.
Is it still sharing?
Yeah, you're still sharing.
Okay, yeah, it's just gone funny on my side. That's fine. So yeah, this is where the self-managed airspace concept comes in. So it's all about making sure you can say, I'm flying here, rather than someone telling you where to fly, essentially. And we've workshopped this idea. So asking various different user groups, so drone operators, general aviation pilots, sort of hobby groups, I guess, what they thought of the different concepts we wanted to explore. And in terms of what was then called Class Lima, but is now Project Lima, it was generally quite positive. So this is overall everyone, and as you might expect, drone operators are a little bit more positive than everyone else, and the general aviation population are slightly more skeptical. But I think certainly as we were workshopping these ideas, the sort of the attitudes towards the concepts were far more positive, because it's essentially come down this sort of route. Otherwise we have to have UTMs everywhere, or there's TDAs everywhere, and it's that realization of we need a solution here. So part of this is we're implementing a booking system. So it's in 4 dimensions, so that is up, down, left, right, but also in time. So very much, I'm going to book this time slot and we're going to fly. We're going to make sure we're at these specific points with a bit of a buffer, but everyone's going to know exactly where we are. And actually, I should just mention, the entire concept rests around transponders being mandatory, so you can still see where people are, but it's not a case of you're being told where to go. So as part of this booking system, this is a little bit of an overview, just a little example over Southampton. So a flight just across the city, you would book it, it would look like a sort of box around your flight, and then it would say, okay, yeah, that's fine, no one else has booked something similar, so your trajectory is authorized for the time that you've booked. Now, if I wanted to do something similar, but it's going to conflict, we'll end up with something like this, and it's going to tell you exactly where you're going to have this conflict. And it's this self-managed nature that we're looking for. So if you suddenly say, right, well, okay, we'll make my flight go higher, or I'll fly at a different time, you can then sort of work together to avoid having this overall management. So this brings me to the Llanbedr flight trials. So for those that don't know, if they're not in the UK, it's in North Wales, so just right up here. It takes a very long time to get there, but it's beautiful, definitely worth a visit. But it's got a dedicated aerospace centre, which is specifically for UAS development, so drone development. And the reason why we're not doing it in the Solent is because if you look at this graph here, this is the change of flights during COVID in Lyon-Solent Airport. So we can see, okay, COVID's really knocked everyone down, but by the time we get back to afterwards, everyone's flying. It's such a busy bit of airspace. We need to be safe. We need to de-risk. And so we also have this danger area available to us, so we can make sure that other airspace users aren't at risk whilst we're testing systems. So what does this look like on the ground? It's very much, okay, we've got our safety officer, he's kind of overseeing things, being a bit of a marshal for everything. It's still self-managed, but we do want to keep things safe. We're going to have that our overseeing operator. And very quickly we came onto this idea of, okay, there are different trials going on, people are testing loitering, and this might be a potential issue if you've got, say, a helicopter's come in, you've got your emergency ambulance come in, and okay, I'm going to have to loiter, so I might need to adapt my booking to book a volume. And so this is something that we realised and implemented quite quickly. And then the next bit is, how do we deal with conflicts? So if someone has outstayed their welcomes, so to speak, they've had their booking, they've had time up in the sky, but then they're still up in the sky, they're not playing ball, and that is where we have our safety officer was sort of managing those conflicts. But it's still something that we want to think about going forward, and how do we ensure compliance? And that is where we have various different ADS-B ping stations. So this is for the people that aren't so aviation minded. This is essentially a sensor that's going to pick up any aircraft pings, and that is why every aircraft needs to be transponder based. And so we can kind of get this visual picture of what's going on, but we don't need to be fully involved like a UTM would. So the system works very much on a first come, first served basis. You get there first, you get your booking. If you're then conflicting, it's someone else's problem to solve. How do you police it? And then how do you prevent misuse? So I don't want a drone flying above my house. I'm going to book out a massive volume. Do we start charging? These are the sorts of questions that we might want to think about. And equally, we could look at potentially more non-infrastructure based options. So various detect and avoid systems might be quite beneficial, particularly if you've got aircraft that are, if you throw a drone at a general aviation aircraft, but it's got detect and avoid, you cannot hit that aircraft. So all these options can kind of supplement each other. And how does this apply? So we then scaled down some of the medical trials that we're looking to do in the Solent, and we tried them over the Llanbedr airfield. So we've got a multimodal delivery system that we've developed as part of the eDrone and Future Transport Zone projects, and we can understand, okay, what's the best mode? And through doing this, you can see in this this diagram here, we were going to have 2 flights to service these GP surgeries, or obviously airfield positions, but mock GP surgeries, and we can fly to those locations without conflicting with each other. And as Paul mentioned earlier, we've got this decision to make. Do we want to fly it? Do we want to use a cargo bike? Do we want to use a van? And it's playing to the strengths of the modes and technologies you've got available. So in terms of next steps, we're looking at new technologies, potentially some BVLOS trials. So everything that we did was VLOS, just to make sure we are as safe as possible. But once we get a bit more confidence, the system's had a bit more of a shakedown, BVLOS trials will be an obvious next step. And then we're going to try and apply it to a Solent case study. So this one here is the full-scale version of the GP collection problem. So we'd have potentially multiple flights around the Southampton area, hopefully deconflicted using this system. So that's a bit of a flavour of what went on in early July, and yeah, watch this space. Thank you very much.
Andy, that was brilliant. A nice little window on what you're up to. And I'm still very grumpy that I got so close to joining you at one of those tests and my car blew up, so I couldn't quite make it. So any questions from the floor? Anybody curious about that particular Lena system? I mean, I've got one. So you were talking about, you know, you're in 3 dimensions, and I've been to a few other presentations where the deconflicting was going to be fairly binary. So larger aircraft above a certain height, drones, UAVs below a certain height. Is that the way of your model and your LEMA system? Is that airspace below a cutoff?
Yeah. So the idea would be everything up to say 400 feet or however, say it might be the CAA that implement it, it might be NATS, big airspace providers. They would chunk out the air, and you'd say, right, well, this is a LEMA transponder mandatory airspace. So you have, if you're going to fly drones, you've got to book, but you can do BB loss as long as you've got your booking and you've got your transponder. So yeah, that's kind of how it would still be segregated from kind of controlled larger aircraft, but it's the quiet regions that we're looking to address. So you wouldn't be using this around, say, Heathrow, but in the back end of Scotland, it could be a perfect solution.
Yeah, or in the southeast where you are. Excellent.
Or in the southeast, of course. Yeah.
So would you, because depending on the aircraft, because drones come in all different flavors, as Paul mentioned at the start, would some of the volumes, would some of the bookings be dependent on the type of drone that you've got, and possibly the type of cargo? Because some cargoes could be pushed back, other cargoes, the person's having a heart attack, they need to get it now. So it's just that time element as well.
This is, yeah, it's a conversation that we're slowly having. Is okay, how do we address priorities? So if Mr. Tom Jarrett, he's got his Amazon deliveries coming by drone at 3 o'clock, but Mrs. Jones has just had a heart attack. Surely she's going to have priority over his new iPhone. So it's a question of how do you address what's higher priority than something else. But it's equally, compliance might be a way of supporting that as well. So if I've got someone who's really compliant, they're always bang on time with their time booking versus someone that's, say, 5 minutes out normally, would they get better priority? And it's these sort of human interaction issues that I think we're still to address. So put drones in the air, no problem. Put humans in the mix, nightmare.
I could rattle on and ask you tons, but David's got a question. David, do you want to unmute yourself?
Yeah, hi guys. Thanks, Andy. I had a question about how you manage, or if you at all have a system for this at the moment, how you manage uncooperative aircraft. So if someone's flying into the TMZ but they aren't transponding for any reason, is that your responsibility to deal with? And
so we do discuss this quite a lot. We term them the Tiger Moth man, the person that they don't want to play ball. They're not involved at all. So the idea of, if you're giving everything, absolutely everything to this person, if they don't want to transpond themselves, that's up to them. But it's a case of, you're entering a transponder mandatory zone. In general aviation, you would need a transponder. So if you're not going to play ball with that, you would be doing it at your own risk, even without drones in the air. So it's kind of, you play with the rules of aviation as a whole if you don't want to comply.
I guess as an extension, has the CAA been happy with you saying, it's their responsibility? If they're doing it wrong, then it's not our responsibility to deal with them.
I mean, it's so it is actually a part of a CAA sandbox, and they are very much involved with the discussions of how do we tackle these scenarios. And so it's still early days. I'm not going to say we've got an answer for everything. That would be very, very foolish for me to say that. But yeah, these are the sort of questions that are coming up, and so they are being addressed, certainly being addressed.
Yeah, it's a tricky one. Thank you.
Thank you, David. Sorry, before you go ahead, what's your organisation, David?
I'm from Connected Places Catapult.
Right.
Former Atkins man as well.
Yeah.
Excellent stuff. That's very good. I've got Tom Shearer. He's got his hand up. Tom.
Yeah, very quickly, Andy. A classic problem with a booking system, just like on the rail service for freight. What's stopping Maersk Line or China Shipping from booking a whole train but only putting 3 containers on it? That's the interesting
It's
thing
a
with
very
this.
good question.
How would you prevent a drone operator saying, "I'll tell you what, well, we could let's book all 6 slots in the morning. We might only use 1, but at least we can guarantee we're going to get a slot and stuff old matey, our rival." That'd be interesting. You know, that's quite an interesting dilemma, and
it might be
happens a lot in logistics.
You start to throw in some sort of cost or a penalty for it. So I mean, if I'm a regular, I'm going to book the 6 o'clock across Southampton, and I only use it 5 out of 6 days, or only use it 1 out of 6 days. That could be some sort of, okay, well, this person has. You could almost view it as a compliance of, have they actually used the slot? If they've not used it, you could view it as non-compliant, and that could then come into the priorities again. So it's this abuse of the system that we need to check, because I mean, if people don't want drones flying above their house, they might well book a lot of airspace that's never going to get used. But there needs to be some sort of penalty for that.
It comes down to who the slot allocator is, who actually runs and manages the booking system. You know,
runs the service.
In rail logistics, when you're up against some of the big shipping companies, you know, you can't turn around and say, I'm going to fine you £10 for booking 38 container slots. You only took 2. Let's go sod off. You know, I'm supplying most of the goods that you buy, mate. I couldn't care less. And in the future, when you know drone companies are pretty powerful, it's a really interesting dilemma. It's what the power of the slot allocator is, and what they can actually do about it. It's a really interesting debate, actually. But yeah, I think that's something we'll have to approach in the future. Exactly. Yeah.
You can almost imagine a kind of a futures market in the slots, couldn't you? That somebody would buy some of these slots and then sell them back to someone, you know, to another group.
It's the next it's the next NFT.
Oh my giddy aunt. Some of that I was very encouraged with, Andy. Now that really kind of does worry me. Good. Any further questions? That was a really good insight. So we've started off with the drone platform. Now we've had managing the airspace. And I think we've got Jens now from Intelsius that's going to talk about a little bit about the cargo and how to protect it. So, Jens, the floor is yours.
Thank you very much, Paul. I will share my screen in a second. How it works. We tested it before, right?
Yep, it was fantastic.
Okay, I hope you can all see my screen.
Hang on, it's great.
Yeah. Thank you again for the time. Just a very quick introduction, because it's the first time I'm in this call, in this meeting, where we are coming from, who I am, and who my organization is. So I'm Jens, in charge for product development at Intelsius. Intelsius is a company developing packaging solutions, dangerous goods packaging solutions, and also temperature critical packaging solutions, mainly used in the pharma industry and healthcare and clinical trials. And we are the lead for a Innovate UK funded project, which is InMed. And the challenge I would like to present to you today is one, let's say, work package or task that is part of this project. The project itself, very quick overview here. InMed is a consortium of organizations. You can see them on screen, and it's very user focused, and you will see in a minute why. So work packages in the project are really focusing on the interface between the drone platforms used and, for example, SOPs or processes relevant for the users, like NHS trusts, and also, for example, anything that is needed for the day-to-day operations, and comparing them to the day-to-day operations now, which is mainly road transport or ground transport. So for the next step here, so the challenge really that we identified in this project is to transport dangerous goods in the air. And this is because that's basically our day-to-day work. So we develop packaging for dangerous goods. We develop packaging for temperature critical materials. So mainly samples, biological substances from the patient to a lab, and the other way around. So usually medicines or any other temperature critical products to the patient, to a hospital, and so on. And we all know all the projects out there to fly these materials from and to hospitals. and a big part of that usually is samples. We know that a lot of these tests done so far are using representative payloads like, you know, water in a vial or so. And because we already have a large portfolio of dangerous goods packaging for biological substances, we wanted to find out what needs to be done to really certify such packaging for drone operations. So the first step really was to identify applicable test procedures and guidelines for dangerous goods, and then develop a packaging variant of a solution we already have that is fulfilling the requirements from these regulations, and then testifying and certifying the packaging ultimately, if possible. So we started off with a packaging which is one of the smallest ones. We have a wide range here that is already VCA certified. The VCA is in charge to certify such packaging for dangerous goods transportation, and we have plenty of them for road and air transport in our portfolio. So we wanted to know what else needs to be done so that we can really fly biological substances, dangerous goods, using drones. So we talked to the VCA, and I assume some of you know. We found out that they published in April 22, so just a few months back, the first ever test procedure for such packaging, which is on top of what is needed for dangerous goods anyway, the packaging to be tested for a potential approval or certification for that packaging to be used in drone transportation. So the focus here really is using the existing requirement, or fulfilling the existing requirements for such packaging, and on top of that, what is needed to approve such packaging for drone operations. So the main task here really for us was to design, test, and certify a crash-proof container. The crash-proof container is what is specified in this test procedure, which basically says it needs to survive a series of tests from operational altitude, and the primary container of the biological substance need to be leak-proof after an impact on a hard surface, so ideally concrete, from operational altitude, and that this is something you can replicate and show that it is possible and will survive all the time. So we started to design a solution that is basically kind of a safety rubberized overpack, let's say, to the already certified packaging for ground and air transportation, and then wanted to see, can we get an approval from the CAA here to do a drop test, or the series of drop tests required based on the new guideline or the new procedure to actually test and drop this packaging. So our operational altitude for the use case we had in the project is 60 meters or 200 feet. And therefore, we wanted to find out what we need to do to start this series of drops. So we designed the test procedure in compliance with the guideline or the test procedure, and we also had identified an airfield which is suitable, which Intelsius is a York-based company, so Alvington Airfield is just around the corner, actually across the street from us. And it was very convenient for us to talk to them, especially because there's not a lot of traffic. So it was quite easy for us to find out that they're happy to support this as long as we have CAA clearance for it. So we submitted our test procedure to the CAA with everything that's needed, like a risk assessment and so on. And we received an exemption for drop testing for a series of days, and the notum for it was published. So we had a few days to actually do the test. But we also found that dropping something from a drone is getting approval for that is much more complicated than, for example, and this is where the platform we used for the drop testing came in, from a weather balloon, because in the guideline it says nothing about that it needs to be a moving object or so. It says a lot about weather conditions, flight, the altitude, and all that. But we went with the idea to drop from a weather balloon from 60 meters or higher at a later stage, because we would like to add more drop tests in the future to the series of testing, also other sizes of packaging and all that. But we started with the smallest one from 60 meters to prove that this way forward is works for us. So, and then obviously a remote controlled release of the payload, and a minimum of 3 individual drops from that platform. So we did that for the first time a few weeks back in Elvington, and dropped actually 5 times for the first series. We will have another series of tests next week, and the result for that was that I said the minimum was 3, what we dropped 5 times. All of the primaries survived the drop onto the concrete area of the tarmac of the airport, and we would like to proceed going forward with the same test procedure. So ultimately, the goal here is that we submit all the test results, and finally then hopefully also have the chance to get an approved packaging solution that can be used. And actually, this is just for the minimum requirement of a few vials in a very small packaging, very lightweight, and the challenges will grow with larger packaging and larger dimensions, and maybe temperature control involved, because this packaging is non-temperature controlled. As soon as we have passive coolants and insulation and so on, this might change. So we need to do all this testing again for all sizes and all variants of the packaging. But for a first step, we are very happy with the results, especially because we now have a procedure we can follow for future tests for other sizes and so on, and we will continue to do that. So that's basically the outcome of our work package here in the project. Paul, any questions?
Brilliant, thank you, Jens. I really like the test venue. Fantastic. Not a lab, a weather balloon. Brilliant. Any questions from the floor? I've got a very general one. You kind of raised the points that this is the first step and many variables need to be tested. But do you think the procedure and the process that you've developed, is that transferable to those more complex sort of types of packaging and samples that you've got?
Dropping from higher altitudes requires a different exemption. 60 meters is easier, especially combined with a weather balloon. It was the easiest way to get an approval for dropping something. Yes, it will be more challenging, absolutely. But the technology, the weather balloons, they're quite, I think there's quite some scale in there going for larger packaging solutions. When we're talking about dangerous goods and non-temperature control, even a packaging for, let's say, 100 vials or so, or cryo boxes, then we have temperature control involved. But a few kilos, let's say, no problem at all. If we're talking about really much bigger payloads, like, pellet-sized, temperature-controlled, insulated solutions we have, probably difficult. At some point, you might need to use another platform, because it would be a quite big balloon.
Ooh, yeah. Obviously, if things go well, we get size is important. Yeah. Tom, you've got a question.
Yeah. Can I just ask exactly what you're dropping here? I'm just trying to look on the photograph. Is it in a box? Was it in a VersaPack? What's it? Did I miss a slide?
It is. No, let's have a look. I can show you.
I'm just trying to get my head around on what the unit is.
You can see this image now here. There on my screen, right? So we had 3 vials with actually colored water,
Yeah.
so we did not drop blood here. They go into a bag with an absorbent, which is a product we have. It's a pressure tested and liquid liquid tight.
Standard 3-layer packaging. That's what you were using.
Yeah, actually, yeah. Sorry.
But what was that in? Was that what was literally dropped?
No, it was in. You can see this here on top. It was in this rubber, X-shaped.
I see. So it's in a box. It's in a box with that shield around it.
Yes, and the shield is basically protecting, because the drop should hit the surface, ideally on the corners and every surface of the packaging. Yeah. So, and then therefore we try to we developed a very lightweight rubberized case around the box that basically protects the areas where we know is the most prone to damage of the packaging. Yeah.
And how far did it move away? When it was let go, how far did it drift across? I'm just thinking of the weight of that, and that's one of the biggest things with this, because we're looking at dropping a VersaPack. We're just getting permissions at the moment, and it's interesting whether a standard VersaPack could actually, with your VAR, whatever it is, in 3-layer packaging within a VersaPack, to what extent that might, be good enough. It'd be very interesting to see. But the biggest issue is actually, dropping it from the operational heights is a bit crazy, because you reach terminal velocity. You don't need to go to 400 feet, and it's just lethal trying to drop stuff in testing. And it does beg the argument: is there a way of doing this more safely in some ways? But yeah, I laud what you've done there. It's excellent.
I know that there was very early in the conversation with the VCA and the CAA about this drop testing procedure. There was the question also from our side: can we work with terminal velocity? Because we know, especially the lightweight packaging will reach terminal velocity very, very quickly. You don't need to drop 60 meters at all. Exactly. But then and we wanted to drop and test quickly. And I said, yeah, maybe there's a discussion on how to make sure that you calculate the right terminal velocity, especially for a packaging like this that may turn around all the time in the air and so on, and the surface is different every second. So we went with a process to say, let's drop this very lightweight one first, and then maybe go to terminal velocity approach later. For the question for drifting, actually not too far. You know that in the procedure, I think it's 30 meters or 60 meters, and you're not allowed to move outside, otherwise it's invalid. And it was okay. For us, it was okay. Yeah, okay. But we picked we monitored the weather quite closely and picked dates with very low wind. In the procedure, it says under 10 knots anyway, but ideally you want less.
Yeah. Okay. All right. Thank you. That's really, really interesting. Thank you very much.
Excellent stuff. Good. We're there, and we're bang on time. Oh, is there some more hands up? I can't see. No, I think we've answered all those. So, Jens, thank you very much. That was a very instructive presentation. Thank you. I think we're bang on time now, which is good. So, Patrick, you're up next.
It always works better. Thanks, Paul. So I'm going to try and say a few words here that bring together some of what we've heard in these excellent talks before from Paul, Andy, and Jens. Make that full size. That'll probably help. Is that better?
Yep, that's better.
Okay, so a bit of background on myself. So I've been working closely with Paul in this area. Paul's been the kind of the face of DRACHMA, but behind the scenes we've been working closely. My background has also been around laboratory robotics and automation, and there are some aspects there that I'm going to bring to bear in a moment, where it's much more, it's about using robotics of all kinds, probably a bit less drones, but to try and make the work a bit more easy and reliable and accurate. So some of the same themes we see within drones, but within a lab, and the drones of course take us out of the lab with the medicines and into the patients and the samples and the types we've heard before. So let me carry on. I'm going to talk more about the data. So we've seen images of drones, we've seen images of packaging, which are absolutely essential for what we're trying to do here. But hidden behind all of this, I think, is a story that's worth mentioning. Oops, let me go forward a slide. So I'm going to talk a bit about the data. I'm going to pick an example of sharing data, the UpDog database, and I'm going to talk a little bit about something called FAIR data. So data that is fair, and you'll see what that acronym means. So let me move on. when we diagrammatize what we've been talking about here in this DRACHMA session and of course in the wider world beyond, we're looking at a situation where the physical world is about moving drugs and materials and diagnostics and patient samples in the classic van, bike, sometimes motorbike, sometimes on foot even. It's manual, it's informal in the sense that there's somebody in the loop, somebody looking after it, making sure it happens. We've got some issues of a big effective load in the van. The range is okay within a certain spectrum, and it's not very sustainable right now. It's diesel, petrol vehicles. And we're all very excited, I think, at the possibilities of using drones, which will be potentially faster, straight lines, with the caveats that Andy talked about, and smaller loads. So we don't use all of the equipment and the burden where we have to put one sample in a big van. But that's really focusing on the physical side of things. If we take a look a bit at the digital side of things and what users are actually interested in, they're interested in answering questions like, where is my sample? When will it arrive? And will it be okay? And there, of course, the drone can help us, but it helps us more if we think of it in the digital sense. When we have a van and we have somebody in the van with a mobile phone, they can answer some of these questions, not all of them very easily, but many of them. When we have a connected drone, and our drones will be connected for the safety reasons that Andy alluded to, we also have the possibility of answering these questions in real time through the infrastructure, through the services, which will be established around these drone services, as Paul was talking about in the first talk. So I want to dwell a little bit about what it means to be taking into account not just the physical side of this, but the data side of this. So when we talk about the role of the data, it's important for users, the economic case, the quality, the timeliness. Paul gave a very good outline of this in a slightly different perspective in his presentation. The drone operators, can we make this work? Can we be effective? Can we be cost effective? From the regulator's perspective, it's our role, I think, a little bit to help the CAA and the others to understand what it is we're trying to do here and to provide evidence that we are actually credible, reliable, responsible participants in this broad ecosystem, which includes many people who are perhaps a little bit on the wild edge, the other drone, hobby drone and general aviation. And of course, the public as well. We heard some comments made about noise, but when we talk to the public, we often hear comments that are very supportive of what this would do. Certainly in the UK, the enthusiasm and support for the NHS is almost universal, at least in the principle of the thing. So the public, bringing them on board and showing them examples of what we can do. And another group, of course, is the public funders and the publishers who are interesting to us as in the academic world, but also through the press, as we've heard this morning on the BBC. So these groups are interested in seeing what is the evidence that this is done. And the full basis of science and progress through reproducibility is based on this idea of data that we can share. And we sometimes forget about this and our enthusiasm to rush ahead and show what we can do. So one question that raises itself is, where are we today with this? And I'm going to be talking next couple of slides on the UpDog network. And I'm very happy to see that Gabriella and her colleagues have joined us today. And so I pilfer mercilessly from the great work and give her full due credit to the UpDog portal that Gabriella and colleagues at Village Reach in Canada told us about during the last year. We're delighted to discover this is a database which is publicly available in several languages, English, French, Spanish, and others, where you can take a look at the data that's currently available on what drone deliveries have been carried out. Payload delivery working group, this is continually being updated. You see there the front page of it, and you will find it very easily by doing a search. And if we dive into it, this is the kind of information we see. So this is unsorted, all of the data. So you see by country, what the projects were, what phase, they categorize it into different phases, when it was done, how it was done, what drone supplier was being used. And the drone supplier is an important but not the only participant in this ecosystem, and the number of flights. And very quickly you see that some efforts have been small exercises, small number of flights, and in other places it's been really very large numbers of flights indeed. And then you click on learn more, you will go down into deeper levels of information about what's been done among the publicly available information. So this for me is an absolutely fantastic initiative to bring together and to share the nitty-gritty detail of what's been done, and not just have to rely on press releases if we know what they are like, or on what's been published in the general media, to really look at what's been done and to try and close the loop on the practice across the world. So what does this mean if we look at science more generally and how people are trying to share data in all the different aspects of science? This has been a very hot topic in the last couple of years. This is a slide from a workshop that was held last year by one of the standards bodies, ISO and CENELEC, called Putting Science into Standards. It's also Putting Standards into Science, where they're developing an ISO standard to harmonize data sharing so it can be done, the formatting is done, the description can be done. This particular focus is on life sciences, which of course touches on us in medical. And the images there in the middle is a classic example from bad practice in science from way back, 1904, when there was a big fire. This is a famous example in the standards community, but perhaps little known outside of that, so I dwell on it a little. When there was a big fire in the city of Baltimore, so big in fact that the authorities had to send fire engines from neighboring cities of Washington and Philadelphia, but they unfortunately found that the couplings of the hoses did not work in the city of Baltimore because Baltimore had its own standards and nobody had thought to standardize the coupling. Of course, these days this is all standardized and done, but we had to live through a rather painful or extremely painful and indeed fatal example of what happened in Baltimore in those days, and the need for harmonized interoperable standards, physical standards of connectors, and we have all those now in our mobile phones with various USBs, but we're still learning how to do this with data standards. So turn now to FAIR data, so to enable us to share within the organization and across the community, to replicate our work, building upon the work of others, and also in recent years, try to leverage the new tools that are coming out of artificial intelligence and machine learning. We need to produce data which is available, accessible, readable by humans, but readable by these poor machines that are somehow a little bit disabled compared to our superior intelligence, at least at the moment. We also have to respect rules on confidentiality and proprietary matters of interest here, the security to prevent bad actors from hacking the code and delivering various nonsense and indeed dangerous elements of the code, so that we can really work together and build together. So FAIR is an acronym that's been developed largely in the life science community, but now broadening out much more widely, and I bring it here to this community. F is findable, A means accessible, I means interoperable, and R means reusable. Okay, what does that really mean? Findable, it has a digital identifier. Any paper that you will read now usually has a digital object identifier, a DOI, and the publishers are brought on board. It has searchable keywords, which are still somewhat in development, but at least we know when we're looking for data articles, we know what those are. So findable data would also have these. Accessible means that we can drag it out of the web using a protocol which is not proprietary, and we know we can prove who we are, we can prove where the data came from. It's interoperable, so the metadata is shared. We know that the distances are measured in kilometers, miles, nautical miles, any of those nice units, but we know what they mean. And it's reusable. So the metadata, data about the data is relevant, uses terms that we know, and we can show the provenance of that data, so that it's genuinely good quality. I think OpDog already does a large amount of that already at the level it's currently operating. A lot more detail in here. I'm not going to go into any detail, but again, it's to show that there has been a lot of work done in the background in other communities on how to implement FAIR, how to share data using FAIR, and there is a lot of good practice out there in the community that I think we can leverage. So what would be next? So OpDog, I think, has a fantastic role in establishing that it is worthwhile and useful to have somewhere where we can store and access data. But what's needed now is more useful data, more diverse data. It's already very international, but the number of different vehicles that's used, the number of different deliveries does not represent the whole of the world. And we can also have more detailed data. So what's actually happening in those individual flights? What happened at the temperature, at the wind speed? Some of the things that Jens and Andy were talking about in their talks. There's much more nitty-gritty data that we would like to have access to. And we also need better tools. So the model ontology. So we really know what we mean when we're talking about shock and temperature and the journey of the package, and that we have scripts and visualization that we can anchor ourselves in some of the AI and machine learning tools. So we'd really love to see some of that being applied, and that makes the data much more useful and gives us many more insights than we could otherwise have it just by staring at it. I'm going to come back to this diagram there and make an appeal also that we We want to go to the drone delivery, but going to a pure drone proposal in the physical world maybe misses out one of the steps, which is to digitize business as usual. So this is touched on in the earlier talks, but when we take a sample and put it on a bike or put it on a van, then what is the times, what are the shocks, what are the temperature excursions that those samples experience to help us answer those questions from the user? Will it be okay? And then taking that and comparing it to the connected drones helps us to build use cases and convince the users that there are benefits in certain cases. As Paul said at the beginning, not every case in a city may be worthwhile, but then we start to have a much richer discussions about where drones play a role and can benefit us. So the last couple of slides just in closing is we love to see these pictures, a drone, a reliable drone with many rotors, flying in a nice blue sky, doing a trial of transfer that we think will be valuable to our nearest and dearest in our communities in the near future. If you look carefully at that picture, it is a blue sky, but you've got an interesting feature in the back, not the cloud, but the contrail. And when we look at our clouds, our skies, maybe less right now, but two or so years ago, they were really full of these contrails. So that was that world of richly overlapping flights, which were well controlled, well trusted, and only extremely rarely resulted in near misses and accidents. And you can look at tools like these, which initially as a passenger look extremely scary, but as you zoom in, you see the exquisite choreography, if I can call it that, that's happening at the level, the detailed local level, to prevent these flights from colliding. You see the helicopters, you see the general aviation, all the different vehicles, gliders that do not collide. They're well managed. And we still have to learn to see that in our drone world. So we see a lot of images in the press of the left-hand panel with one drone in a beautiful blue sky. And I was gratified to hear the discussion on temperature and winds, because we will be seeing many drones, and it will look scary to the general public, the image on the right-hand side, when we do not feel yet confident that these are choreographed to the same level as we expect to be for general aviation, for the aviation that we rely on day to day to transport us and our goods. In closing, let me go back to an earlier time. This is from 1900s. You know the vehicle and you know some of the stories, but reading the reports from the time, you would be insane to go into the sky in something that was heavier than air. If it was lighter than air, you could be sure that you would float and it would be fine. We now know better. We know that some of the properties of some of that lighter than air technology were not what we could trust, and so we've moved away from that to the vehicles that we've currently seen. However, there's one small village in Germany, to paraphrase Asterix, where this is there's some people still holding out. I live in Constance, and across the lake in Friedrichshafen, we have the Zeppelin, and every day I look out the window and I see one of these lighter than air vehicles fly across my window pane. Zeppelin Friedrichshafen is in an interesting situation. It is the constructor of these vehicles, it is the operator of these vehicles, and they're mostly pleasure flights, and it is also the MRO, so the maintenance organization. These have been separated in other forms of aviation because we can trust each of those to do their work and have a correct handoff. We haven't quite got the situation with drones. We're not killing people, there's no big incendiary event, but ZF manages to maintain all of that data and maintain the trust of the local CAA in order to keep these flights going. So I'm looking forward to a time when I can look out my window and see the regular drones fly past and not just the helium-filled airship. Okay, that was a whistle-stop tour. I'm happy to take any questions, but I know that Paul has another slide that he's dying to share with us.
No, I thought that was brilliant. I'm going to have a go on that Zeppelin. It seems fantastic. Any questions from the floor? I think you picked up a really good theme, actually, Patrick, that was kind of demonstrated by nearly all of the speakers, this sort of separation in the different functions and processes. And I think Paul started that off really superbly well. Do part of the job, connecting to another part of the job, and that's going to do very well, I think, for the development of the sector. And it's kind of coming through now, isn't it, with this kind of sort of super highway. There's lots of not low-hanging fruit, but different questions that we've got to answer, I think, really. So
calling it a highway also kind of creates this metaphorical, this image in your mind that it is a safe place, a place you can trust, because the open skies don't have that on their own.
Absolutely, absolutely, and there's a boundary as well. So is the highway going over my house? Some people would like that. I quite like the sound of the trains and the drones overhead. That's, I would have guessed many people would not. So that's good. So if I may, because I think we're all starting to wilt in the heat, and thank you, Patrick, for that presentation. But stay on. Patrick's gone. I was going to hope.
I'm still there. I'm still there.
Yeah, that's good. Yeah, stay on, Patrick, because you're part of this. So we're going to go back in the last few minutes. We're going to talk about the special issue. So in the background, Patrick and I have been talking to drones. Is it NDPI? I always get that round the wrong way because I'm dyslexic. They've published many of the speakers' work actually in today's meetings and in previous meetings. And we had a very successful special issue which closed about 7 or 8 months ago. And I'm just going to get my highlighter here. And so we've had some good responses from that. There's some good citations. One of the papers has been cited over 20 times, many of them between 5 and 10 citations, with only in a few months of being published. So the publishers like what we're doing. So the idea and the challenge from them is, can we do another one? So we've come up with this sort of title, Evidence-Based Drone Innovation and Research in Healthcare. And we're hopefully going to start to gather up some of the fantastic innovation and research that you guys are talking about, but also, you know, outside of this group as well. The special issue will be launched in September. And this was just a kind of first slide to get the conversation going. Drones, the journal, very impressed. Impact factor. The journal itself has only been out for, I think, a couple of years. So, okay, for some journals, you know, we're not double figures yet, but that's respectable. But for aerospace engineering, it's in the top quarter. It's ranked 11th out of over 100 different titles, which is good. And this is the kind of thing that we published last time in the special issue that we want to continue and improve on going forward. And just to draw your attention to one of these figures, what is interesting, integrating new technology. I didn't notice this when the paper was reviewed. There's a Brompton bicycle in the background. So Paul's very early comments about getting the operators, the loaders, close to the drone itself is a requirement. I'm going to say something that's a little bit off the record, but one of the things that was interesting is that drones, the journal itself, has a very broad reach of people building drones, the operating systems, the impact of drones, the individual components, right through to the modeling of the airspace, digital twins, all that kind of stuff. But quite a high proportion of the authors and reviewers are kind of engineers. And this particular paper here, we had a bit of a hard job getting it through because each of the individual pieces I thought were very good, but yes, you know, they were developments of existing technology, but nobody put the case all together as these authors have done in terms of building a drone that was fit for purpose, building the software and the safety systems to get it to a patient and deliver the defibrillator and then test it in the field. And I thought this was very good. So in terms of the special issue, if you have some of your papers within that umbrella, we can't publish bad science, but we can protect possibly studies that would have got possibly rejected or a harder journey through. So these are the kind of thoughts that I had about the special issue. And please correct me. I think we've got sort of 3 areas that the kind of papers that contributed to the last special issue should be continued into this new one, which is obviously something about the drone, something about the cargo, and something about the safety, and they all interconnect. So the drone, what type of drone? What drones do we need to develop in the future? There's a kind of a cutoff that's going on at the moment. The 100K drone, the 50 kilo drone that can transport a big cargoes, and then the drone that gets to the patient point of care, that can deliver the vital medicine to the patient anywhere. And those kind of drones are much smaller. So mass and volume really important. Power and propulsion, the thing that I kind of picked up from your presentation, Patrick, and from the earlier ones, is some of these standards. You know, it strikes me that there should be some kind of battery standard. There's quite a lot of the operational cases. There's a lot of time spent about, do we have at the destination enough batteries to then allow the drone's return journey if the weather suddenly changes and the wind speeds double? So surely we should have some interchangeable batteries. There's probably an area there. And something that was mentioned earlier on about airworthiness, who's testing that? Who's done that in terms of standards? And then safety, you know, what are all the control systems that are being developed and the research associated with VLOS, EVLOS, BVLOS, and full automation and things around collision avoidance, congested airspace, superhighways, the stuff that Andy was talking about, and then the perception and the community. And what was nice, that came through in all of the talks, from the regulator, from the ends piece, but also from Paul's piece and Patrick's piece and Andy's piece. And the bit that I'm interested in, obviously, is the quality control and the quality assurance of the medicine and the biological and the medical samples that are being transported. Can we integrate that? How do we integrate that with business as usual? Are we pushing back a problem? Is the porterage, is the people that are having to unload things and reload things on the drone, can we automate their processes, you know, or do we have to train them in different skills? Point of care delivery, you know, do we need almost throwaway drones that are very lightweight, that can get to the person very quickly, but if in their journey the patient who's having a heart attack steps back and falls on it and breaks it, well, we haven't got a problem there. Is that possible? And then impact user cases, but also measurement of outputs. I think there's been a lot of really good trial work now, but mapping what was the impact on the local community in terms of their health outcomes, that would be really useful. That's kind of a call to arms, you know, but anything else in between that's within that remit will be welcome, and it'll all be done with the FAIR principles. I don't know. I mean, we've got a minute left, and of course I've spoken too long, so sorry about that. But at any points that the floor would like to add, that I could add to my blank slide there, anything that I've missed off that you think we should add as a kind of outline for this special issue? Patrick, have you got any thoughts? Anything that I need to include?
Well, no, just to re-emphasise on the. Oh, we've got someone coming in. Andy?
Carry on, or should we switch to Andy? Andy, are you there?
Switch to Andy. Yeah.
Yeah, so the economics of drone delivery, because I think it's so often overlooked. It's, let's throw so much money at this, and I mean, you look at Deliveroo and Uber, they're still yet to turn profit. Why on earth do people think that drones are the answer to every solution?
Because, as you probably know, I'm slightly disorganised.
Yeah, there's very little literature, so if people have numbers to share, it'll be very welcomed.
No, I think I agree completely with you on that. I think the fair aspects, or the evidence-based aspects, is about providing that information, and we have to understand, and I think we all do, that there are commercial and proprietary interests at stake here. However, keeping everything hidden to oneself is not productive for us overall as a community. So the modelling, some general modelling, some sharing of some of the information, I think is going to be essential for us all to see the economic cases being built, and to rule out certain areas because there's a missing thing that we didn't know about. So that, you know, which then leads to new research questions. We've got to have those conversations about the economic case. Absolutely.
Excellent. So I think I've kind of captured that in that little note. Anything else from the operators, perhaps? I guess that the academics have got a bit more freedom to explore some of these issues, but anything that you found that's there's a user, you know, there's a knowledge gap in the literature. I think we're all starting to wilt a little bit here, aren't we? Well, I think we've captured a good point there. So thank you, Andy, for that. And the very last slide, this is just a reminder to put into your diaries. We're going to have a month off in August, so we can go to the seaside with our buckets and spades and have some time off. But we'll be back on the 2nd of September at 3 o'clock. And we've got a couple of speakers lined up, which is kind of a nice two-parter. We've got the operator or the developer of the actual aircraft, Wingcopter, who's been doing some fantastic work in Malawi, and that's Andy, and she has been working in collaboration with it's Amit Singh now. He's agreed to present, and he's head of drone operations for the South African National Blood Service. So a very nice couple of connected presentations there. And then more formally, I'll give some more details about the special issue. So I think we're just about there, aren't we, Patrick?
That's good. Yep.
Good. So I'm going to stop the recording and wish you a very good afternoon. And thanks again to the speakers.